Hello everyone, today's question is LRU CACHE. Design and implement a data structure for list recently used cache. So it support the following operation: get and put. Get key. Get the value of the key if the key exists in cache, otherwise return -1. So put key and value, set or insert the value if key is not already present. When the cache reached its capacity, it should invalidate the list recently used item before inserting any new item. So I hope you understand these questions, what you have to do. So okay, let's move to the pen and paper and understand this problem more clearly. According to this problem statement, you have to do both operation in order of one time complexity. Here is our input data 1 2 3 1 4. So basically, what is cache? Cache is a one type of memory where we store most frequently used data to improve our system performance. And basically there is some certain size. Here size is 3. And now what we will do here, an LRU cache is an efficient cache data structure that can be used to figure out what we should evict when the cache is full, and the goal is to always have the least recently used item accessible in time. Here our first input is 1. We just check the first input is present in cache or not. It is not present, and check size 2 and simply add it in cache. Okay, now our input is 2. So first we look in this cache, we look up in cache, and this value is present or not. If this value is present, we put it in front and we just move 1, and now we check 3. So our inputting function, we just check the value is present or not. So we check here 3 is not present, so we simply shift all the values. So now we check for 1. This is our recent used value. So now we check 1. So one more thing, whenever we check the data is present or not, and if data is not present, then we check the size also, it is within the scope or not, within this size or not. Now 1 is present, so simply we shift 1 to 1 position font, means recent position. So okay, now we check for 4. So we check 4 is not in this cache, and now we check size. So size is 3, and now we have to pop out one element, mean here 2 is old value of this cache. So we just pop out this value from this cache and add the new value in this cache and replace all the value. Pop out from this area, and now our recent use data is 4, 1 and 3. So this is our approach. Basically this is a brute force approach for the solution. Here the time complexity of this solution is for look up in this array, this is order of n, and replace and shifting this position, this is also take order of n. So for searching order of n and replacing the value, that also order of n means order of n plus n means order of n, but we will improve it. So now instead of using array, we will use stack, and whenever we put the data in stack, we use a key value pair before putting this data in stack, and just for improve the lookup time. And now this is our stack, cache stack, and size is also 3. Yeah, before putting this data we check one thing, this is present or not, and if it's not present we check the caches length of cache. So length of cache initially is 0 and check, we simply put this. Okay, now we check if it is exist or not. So we search, if it is not exist you check whether the cache size is already at limit. If the cache size at limit, then we add the value in this cache with the key value pair. And now we again check 3 is not present, search and check limit, and then add and maintain the order. And now we check for 1, and as you can see 1 is already in this array, so you get the key value pair and update the value and put the pair at the top of this stack. So now 1 is on top, means most recent value is 1. So now we check for 4. So we check 4 is search 4 is present or not. So 4 is not present, and here size is also 3, so we have to pop out one element. We'll pop the first in first out manner, means here at bottom value is 2, so we just simply pop 2. Our new updated value is 3, and 3 1 and 4. We always put the value with key value pair. Just understanding purpose I use this stack, but when we use it in our program we use Python order dictionary that will maintain a order. And I hope you understand this problem. It is order of one solution. And now I will write this code. In constructor we declare capacity equals to capacity, and self dot cache equals to we import it from Python collection library, from collections import ordered dix. Okay, cache equals to ordered dix. Now we will move to put function. Whenever you are putting a key value pair, you have to check whether the key already exists or not. If key is already exist, mean key dot cache dot key is exist, then you get the key value pair and update and put it the pair at the front of this cache. So cache dot move to end means, and here simply put the value in this key. And if the key is doesn't exist, you just check whether the cache size is already at limit or not. So if the cache size is not a limit, then simply we pop the last element in FIFO manner. So last we put the value equals to cache key equals to value, and now we perform the get operation. Whenever you are getting the value of the key, check whether the key is exist in cache dot get key, and if exist, put the key value pair at the front of this cache and return the value. Self dot cache key, and if doesn't exist, then return -1. If it is present, then we return the value, and if it is not present, then we simply return the value. I hope you understand this problem. Now we will run this code. Yeah, that's my bad. I'm here using the value, so I just return to cache.key. Oh, again there's a runtime error. Okay. Key is not defined caches, so we have to use self dot cache. Okay, that's all. Yeah, yeah, running successfully. Check submit. Okay, got submit. If you have any doubt regarding this problem, you can comment below. I will try to help you as soon as possible. If you like this video, please give me a like, and if you are new to this channel, please consider subscribe and hit the bell icon. And thank you for watching this video.